Hi, this is Mrs. Allen, and in this video we will be looking at three-dimensional figures. Example 1. Identify solids. Identify each solid, name the bases, faces, edges, and vertices. Okay, so let's look at our first picture, and you name a polyhedron by its bases. So if we look at the bases are hexagons, so this would be a hexagonal prism. Now let's name its parts. So the two bases are hexagons, so the front one would be called hexagon A, B, C, D, E, F, and the back hexagon, the back base, would be called hexagon U, V, W, X, Y, Z. Okay, let's name the faces. The faces are quadrilaterals. So the first one, let's name the one on the top, so quadrilateral AUVB, and going around, the next one would be quadrilateral BVWC, and the next one would be quadrilateral CWXD, and then quadrilateral EYXD, and quadrilateral FZYE, quadrilateral AUZF, and that is all of our faces. Now let's name the edges. First I'm going to name all the edges that are making up the front hexagon. So I have line segment AB, line segment BC, line segment CD, line segment DE, line segment EF, and line segment AF. Now I'm going to name all the line segments that make up the back hexagon. So I have line segment UV, line segment VW, line segment WX, line segment XY, line segment YZ, and line segment UV. And finally I'm going to name all the ones that make up the sides. So I have line segment AU, line segment BV, line segment CW, line segment DX, line segment EY, and line segment FZ. Okay, now we can name the vertices. The vertices are all the corners or the points that we have. So I would, the ones making up the front would be A, B, C, D, E, F, and the ones that make up the back are U, V, W, X, Y, Z. Okay, let's move on to another picture. Here, remember we named the polyhedron by its base. The base is a pentagon, and the five faces meet at a point. So this solid is a pentagonal pyramid. So let's start by naming the bases, or the base. There's only one base here, so it would be named pentagon MPRST. Now I'm going to name the faces. The faces are made up of the 5 triangles that go around the pyramid. My first face would be triangle OST, and my next face will be triangle ORP, and my next one would be triangle OPM, and my next triangle would be OMT, finally triangle OTS. Now I'm going to name all of the edges, and the edges are just the sides of it. So I have all of the edges making up the base, which are line segment MP, line segment PR, line segment RS, line segment ST, and line segment NT. Now I'm going to name all of the edges that make up the sides or the faces. I have line segment OM, line segment OP, line segment OR, line segment OS, and line segment OT. And finally we have the vertices, which is just all the corners and points. So around the pentagon I have M, P, R, S, and T, and then they come to a point O. So my last one's O. Alright, our last picture here. This solid has 2 circles as bases and no vertex. So this is a cylinder. So I'm going to start by naming the bases. We have 2. We have circle A and circle Z. Now I'm going to name the faces, edges, and vertex. Since this is a rounded figure, we have no faces, no edges, and we don't have a vertex. Okay, example 2. Surface area and volume. Find the surface area of the triangular prism. So the first thing we want to do is write down our surface area formula, which is the perimeter of the base times the height plus 2 times the area of the base. So my base is the triangle. So I first want to find the perimeter of my triangle. So I'm going to add up all the sides of my triangle. 10 plus 6 plus 8 equals 24. So my perimeter of the base is 24. Now I want to times that by the height. The height can be found by looking at the distance between the two bases, the two triangles, which is 7. Now I have 2 times the area of the base. Well, my base is a triangle, so I want to use the area of a triangle formula, 1/2 base times height. So I'm going to have 1/2 times 6 times 8, which gives me 24. So if I solve this for the surface area, my surface area is 216 centimeters squared. Okay, part B, find the volume of the triangular prism. So the first thing I want to do is bring up my volume formula, which is area of the base times the height. Remember, my base is the triangle, so I'm going to find the area of my triangle first. And I do that by using the formula 1/2 base times height. So again, 1/2 times 6 times 8 gives me 24. And now I want to look for the height. The height is the distance between the two bases. So between the two triangles is 7 centimeters. So I'm going to plug in 7. And my volume is 168 centimeters cubed. Okay, let's look at example 3. Example 3 has to do with volume. So we have a question about pools. The pool at a community center is in the shape of a rectangular prism with a length of 75 feet and a width of 32 feet and a depth of 5 feet. The manager, Miss Thompson, needs to know the surface area of the pool before she has it repainted. Find the surface area of the pool. So the first thing I want to do is bring up my surface area formula. The surface area of the pool consists of the 4 sides and 1 base. Okay, so the first thing I want to do is draw a picture of this pool and label it. Okay, now I can start plugging into my formula. So the perimeter of the base would be 75 plus 75 plus 32 plus 32, which gives me 214. I'm going to times that by the height, which is 5. And now I want to add that to the area of the base. So my area of the base will be 75 times 32, which is 2,400. So my surface area is going to be 3,470 feet squared. Okay, part B. If Miss Thompson fills the pool to a depth of only 4.5 feet, what is the volume of the water in cubic feet? So I'm going to bring up my formula for volume. Volume equals area of the base times the height. So I first want to find the area of the base. I do that by taking 75 times 32, and I get 2,400. And then I want to times that by the height, and this time I don't want to use 5, I want to use 4.5 because they only want to fill it to 4.5 feet. So now I'm going to times that by 4.5, and my volume would be 10,800 feet cubed. Thanks for watching. I hope this helps you better understand three-dimensional figures.